So if the previous concept that I talked about it on low pass RL, let's talk about RL high pass. Okay, so let's say you have a inductor connected with R load, okay, parallel. In this case, in previous case or series, right now it's parallel. What do you have? You have a high pass. So how does the high pass work? Is that good job. How do I say? Okay, let's start out with just XL lah. Okay, with a low frequency. This is what we do just now. So if the frequency is low, your XL over here is gonna be low, right? So in this case, V equals to IR. So you take in how do I say? So if XL is equals to 2 pi FL low, if the F frequency is low, inductor will be low, right? So the overall reactance of this and this adds out will be somewhat lesser, right? If you were to remember, if it's a parallel thing, so you have like a hold on. This may not be correct lah, okay? But the overall meaning is that if you were to connect in parallel, you know that the voltage in parallel are the same. So the voltage over here and the voltage over here is the same voltage. So since that you know because this inductor 不正气, so like lousy lah, okay, has provide very little reactance. So the overall summation of them will have a lower resistance. Okay, have a lower resistance than this one. So let's say this one is 500 ohm. So the combined one, it maybe have like 100 ohm in this case. So if V equals to IR again, this dude gonna draw more voltage, right? This dude gonna draw more voltage. This resistor gonna draw more voltage. So if it draws more voltage, maybe I should change a different color. So this one will have a lesser voltage. So in this case, if the frequency is low, as you can see, this is in terms of high pass already. If your frequency is low, your voltage is actually very minimum, is very little only. So the voltage going through the R load is very little because it's being dragged down by the inductor, because the inductor reactance is very small, so it affects the overall R load. You get what I mean? So if the frequency increases, now everything changes. So if the frequency increases, let's say, so the overall reactance for this maybe previously was 500 ohm, right? Maybe this now, if this dude becomes like wow, Super Saiyan mode, so it becomes like 10,000 ohm. Then dude, this is mild, right? So this R compared to this one is different already, right? Because it depends all on the voltage divider rule again. 500 plus 10,000 ohm. So in this case, it's 500 divided by the summation of this one and this one. Yeah. So basically, the amount of voltage will be very minimum over here. So this one gonna eat a lot of voltage now. So this is why as higher frequency, this one becomes higher. So this is the voltage thing that it is lah. Okay. So this is one key thing. So since you know the difference, since you know the low pass and the high pass for RL, and you know that the relationship between RL and RC, I mean, inductor and capacitance, they are opposite of each other because 2 pi FL and 1 over 2 pi FC, they are just simply two different pathways. So you know that this dude is, let's say RL low pass is connected series, right? So for capacitance manner, for a low pass, if you are to connect RC, okay, resistors and capacitor, you're gonna have a parallel circuit connected to the R load. So you see, the high pass one, you connect inductor parallel to the R load. For the low pass, you connect the capacitor parallel to the R load. So this is a key differences between them, which is the Tobalek. So I believe you already understand the R load concept, okay, the RL low pass concept. So same concept applies to to your RC, like low pass and high pass. Okay, so you may find that your okay, hold on. Okay, so in this case, this should be RC high pass. Okay, so in other words, this dude over here is actually R-load. Okay, so for high pass, so these are the two different things. Maybe I should write down. So for low pass filter, okay, resistor and inductor are connected in series, which I show you earlier over here. They are in series. And then if it's a low pass filter for capacitor and resistors, you're gonna connect the R load. So normally you're gonna in series or parallel is normally in terms of connecting with R load. Okay, so R load is like your rice cooker, your refrigerator, or whatever shit. So in this case, RC meaning resistor and capacitor low pass is actually parallel with the R load. So in high pass wise, high pass resistor and inductor gonna connect in parallel with the R load, while the RC high pass gonna connect in series with the R load. So this is basically the concept of if you were to remember where we are, passive RC filter and passive RL filter. So this is the two things. So with this concept, the next video we'll talk about high pass and low pass, and then we'll go to notch and band pass. So I'll see you there. Bye bye.